here's the XCAP page. It's just a Google Code project. There's a release tarball if you go to downloads. There's the 0.8 release. It'll build on a Linux or BSD or probably OS X machine just fine. It definitely won't run on Windows, sorry. And I think the 0.8 release is almost the latest code. There's just a few changes, nothing big, so you can browse the source tree, you can check it out via SVN and take a look at the code that way. It has a man page. It has, if you do XCAP-H, it'll give you some help and that sort of thing. It's somewhat configurable. You can daemonize it, so you can run it as a service on Linux or BSD or OS X machine just fine. It's more or less a capable program, just like you'd expect from Snort or some other network tool. And it doesn't really get you anything all by itself. Like, all it does is just give you all the executables that are going by on the wire. It's up to you to actually do something with those. So if you don't have the ability to run some sort of malware lab or submit malware to VirusTotal to find out what's malware, that sort of thing, then it's not going to help you. But if you do have the ability to run the malware in VMs and look at the network traffic, or to run your antivirus product on the executables to say, oh, well, so-and-so downloaded Zeus or so-and-so downloaded fake AV or whatever, so we should notify them. If you don't have that ability, it's not going to help you. But it can be the much needed data source if you have some network security infrastructure set up and you need copies of the malware that's going by so that you can create signatures so you can get a feel for what these client machines are downloading and running. XCAP can be that much needed data source. So the way this classroom lab is set up right now is all of these machines, if you imagine the switch port, or the switch, then all of these machines are plugged into ports that are on a VLAN that doesn't go anywhere. It's just a local switch, and these machines can talk to each other. And the instructor machine has one port that's on your guys' VLAN and one port that's on the campus VLAN. And I have a Linux machine, Linux VM, with two Ethernet cards, one in your VLAN and one in this VLAN, and it's acting as a router. And all the traffic is passing through this machine out. So this is essentially that network choke point, that Linux machine that you could run that could see all your traffic. I was going to try to tunnel all this traffic out to Amazon EC2 so that I didn't affect Scripps or Claremont, McKenna, or whichever college we're in right now, but I couldn't get the GRE tunnel working reliably. I didn't want to screw around with it. So instead, I have IP tables set up to drops, so you guys can't spam, you can't scan 445, you can't really do all the really bad stuff. All the HTTP network traffic and that sort of thing is still passing through this machine just fine. I'm also running XCAP on the VM, so you can see executables going by. Over the last couple of days, just a few executables have been downloaded. I don't know what any of these are. I mean, I think this is like Microsoft or something like that. Some of these executables are like Windows Update related. I don't know why. Some Windows Update downloads executables in plain text in the clear. I hope that it actually verifies the signatures on them. Otherwise, a bad guy could just like replace the executable on the wire with malware and then get the Windows machine to run it. I suspect Microsoft actually checks the signatures though. And so you can see in the log output, it'll say at such and such time, this IP address on port 80, so this is a web server, sent this IP address 192.168.50.94. It's one of these client machines. An executable of size 1.5 megabytes. It looks like. The machine code was this is the PE header machine code. So this is a 32-bit. This is 64-bit and this is 32-bit. Subsystem. You can have a graphical executable. You can have a console executable. You have a bunch of different subsystems. The default one is whatever 0002. I don't remember. You have to look it up. Is DLL? It's not a DLL. It's not a PE32. Plus, here's the MD5 of the executable. So who knows? That might be malware. This might be malware. I don't know. We could send it to VirusTotal to find out. And so on a live network with a whole bunch of client machines, you'll sort of see this scroll with executables. It only saves one copy for each MD5. So if you see the same executable going by a whole bunch of times, you only get one copy of it, but you'll get the logs saying that you saw this multiple times. So that way your storage doesn't grow as fast as your logs grow. Okay, so here is the lab machine. You want to point your 2 CD-ROM drives. You have 2 CD-ROM drives. Point one at the resource kit and point one at the NetLab CD. So you should have 2 CD-ROM drives, Forensic Resource Kit and one called NetLab. NetLab has malware on it, and Resource Kit's the same resource kit we've been working with. If you only have 1 CD-ROM drive, so if you only have 1, that probably means that you need to edit your settings. You have these 2 CD-ROM drives in the config. You need to check connected. You need to point them at the right ISOs, and you have to check connected.
Where do you do that?
In your virtual machine, in VMware Player, you go to Edit Settings.
Brandon?
Yes.
I'm getting the characters blah 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 are not allowed in the ISO image file. Hit connected.
Yeah, and then hit browse. You have to hit browse and actually choose the res kit. So it's in the desktop Resnet 2012 res kit. And then you have to do the same thing for the NetLab on the other CD-ROM drive. Connected, and then browse, and then desktop, Resnet 2012, and then NetLab. And then, okay. And that should plug them both into the virtual machine. So now you can just close that out. And then you should go to the computer and you should be able to see the, there you go, you have the res kit and the NetLab. Great. I also have Wireshark installed on the virtual machine. So I would prefer, if this were my own lab set up for doing malware analysis and trying to figure out what's bad, what's good, that sort of thing, I would have physical machines, I'd have VMs, and then I'd have a Linux router. And I would do all the packet capturing on the Linux router, and not in the VM itself, but we have limited resources. I considered giving everyone a router VM and then passing the traffic through the router VM, and I didn't figure you guys wanted to mess with Linux at all to get that working. Yeah, I figured it would be quite a headache. So instead, we're just going to capture packets in the VM. And so we're going to run malware, capture the packet, look at it, then use Process Explorer, clean up the malware, and then continue. And then we'll discuss, what did we see, what was the network traffic, that sort of thing. Now, tested all this malware, and some of it works reliably, and some of it doesn't. So let's hope that it all does network traffic that's useful. So I'm going to run Wireshark. I'm going to just minimize it for now. Here's the NetLab. Here we have a malware, and I've named the malware, so categorized it all. I have a bunch of different fake AV variants in here, categorized all the malware. So let's just work on Cybot first. So don't double click on the executable just yet. So we want to get Process Explorer running. And we'll get auto runs running. And again, I would prefer to do this on a, I prefer to have a clean baseline Windows image. Then I run malware, I capture all the packets on the router, and then I just restore the baseline image brand new, so I don't have to deal with cleaning the machine and that sort of thing. But we don't have that kind of resources available to us in this lab. Okay, so I have Process Explorer running, I have auto runs running, I have Wireshark open and not capturing yet, so I'm going to go to Capture, Options. I'm going to turn off Capture in Promiscuous mode. You can't capture in promiscuous mode inside of the VM. So this was inside of Wireshark. I went to Capture Options, uncheck Capture in Promiscuous mode. Okay, so I'm going to hit Start here. So I'm going to start the packet capturing. So we're already seeing a bunch of traffic, NBNS, this NetBIOS name service, So we're going to turn off NetBIOS so we can do a display field filter. So you can just do bang NVNS and it'll turn off NetBIOS name service in the display. It's still capturing the packets, we're just not seeing them. And then we can alt tab over here to our malware directory, and we're going to double click on 7B7, the MD5 of the executable. If we double click on this, we should get the malware running. And hopefully we'll get some network traffic. So double click on it, we should see it in Process Explorer here. So there it is right there. It hasn't renamed itself or anything like that. Running under Explorer. Not really doing anything. And okay, so we do have some interesting traffic here. We have a GET request, get/ing/icon/twitter.png. So let me, in Wireshark, we can, so what I'm gonna do is I'm gonna stop this capture. So you can hit this little stop icon up here, and that'll stop the capture. Now we can go over and kill the process in Process Explorer. Okay, go over to auto runs. You can refresh auto runs and delete any entries that it may have made. Yeah, so this con host thing, delete that. Don't know what's going on here, but I would ignore it. Okay, so now we look over our packet capture. And I'm going to save this packet capture. Just call it sideline. Okay, so now we have the packet capture saved. Now let's take a sort of an inventory of what happened. So it did a lookup. So it did a DNS query for the name psfk.com. That's the malware command and control domain. So if you had DNS logs and you saw clients looking at psfk.com, they're probably compromised. The response that it got back for PSFK was 72.10.50.52. And well, let's actually look to make sure that's the right response. Standard query response. So we can do the Wireshark dissector here. So the query says PSFK was the query looking for a type A. The answer is PSFK type A, class internet address. Yes. So this 72.10.50.52 IP address is the IP address associated with that name. So if you saw netflow to that IP address, that might indicate machines compromised with this malware. It might not. Who knows what else is running on that IP? If you saw a DNS lookup for this PSFK domain, probably indicates the machine is compromised with malware. Then it did a GET request. So we'll see after it did the DNS lookup and it got the DNS response, it then opened a TCP connection. So we see that starting on packet 45. Our machine sent a SYN packet from source port 49,162 to the HTTP port, which is port 80. Sent a SYN packet. Then we got a SYN ACK packet back. Then we ACKed that, so we've done our three-way TCP handshake. And then the client did a GET request. A GET request is an HTTP request. So we can right-click on this. We can go follow TCP stream. And it gets reassembled. So Wireshark reassembles the entire TCP stream. And so our client, the malware, sent get/image/icon/twitter.png v equals 61 equals 83 ampersand tq equals some base 64 encoded string HTTP 1.0, which is unusual. And it set the connection to close, host PSFK. So that's the request. It set the user agent string to Mozilla 2.0, which is ridiculous. That's not even a correct user agent string. No browser's ever used that user agent string, especially the lowercase m. Malware authors just don't even try half the time. And then it got in, so that's the pink. That's the request that the client sent. And then the response it got back from the server was it got a 301 redirect. It says it moved permanently, and then it says it moved to such and such value. Who knows? I mean, this may or may not even be the malware command and control server at this point. This may have been researchers hijacked the domain, pointed it at their own machine, and now they're just collecting botnet statistics. We don't even know if this is the real command and control server anymore. What we do know is that the pink part, the request that the malware sent, that is completely independent of whether or not this is the real command and control server or not. And in fact, if that domain did not resolve, if you saw the bot do a lookup to PSFK, whatever, and it just got an NX domain back, you could set up a little local DNS server on your router and always resolve PSFK to a local web server and then see what HTTP request the bot's doing. So you could make it resolve even if it no longer resolved. So just to see what the bot's going to do after that. So it's really easy to, if you had web server logs, if you had either Bluecoat or WSA or WebSense or some other web server logs, or if you had that Linux machine that was reconstructing HTTP logs with Bro IDS, or if you had some way of getting web server logs, proxy logs, then you could just query your logs for show me any .png file $v equals some numbers equals some other numbers, then ampersand tq equals, and then some basic 64 encoded string. And that's, how often do you see an HTTP request to a PNG file and you have additional parameters after the PNG file? That's really rare. Not only is it super rare, but specifically having the value v and then some numbers. The v61 probably indicates that we're running bot version 61. Who knows what the equals 83 means? Who knows? TQ, who knows what TQ means? No idea. And then what is this base 64 encoded string? No idea. But you could still find all of the malware on your network that is making queries like this. Also, you could find all the software on your network that's requesting with lowercase Mozilla /2.0. That's guaranteed to be bad. So you could find all your bots with just a few simple signatures. And so let me show you on the NetLab disk. So in the NetLab disk, snort, and then if you open up the web malware file, this is a snort configuration file. And sorry, it's really hard to read in anything. This is not a real text editor. You should open it in Emacs or VI or something like that. But if you just search for like TQ, there we go. So I have a signature. I called it gbot instead of cybot. But this is a snort signature. It's looking for JPG $equals. There's got to be one that's going to be looking for PNG $equals CGI $GIF. So if you rerun this bot a whole bunch of times, you'll see that it does different extensions, and it uses different user ID strings. But it's looking for, JPEG $TQ equals, or so this one's a totally different variant because this one's looking for $TQ because it should be looking for. Okay. So the request that we saw was .png v numbers equals numbers ampersand TQ equals. And so if you look at some of these signatures, it's looking for, here we go. So take a look at this one. Autoblock safe gbot 14. Content get is the request method. URI content .png URI content TQ equals content HTTP 1.0. This ID signature will match this bot. I can tell you right now that UCSD had more than 1,000 of these. Not all at once, just a constant trickle of 15, 20, 30, just constantly for months and months and months and months. Just super popular malware. Lots and lots and lots of people got it. I think it came in via Java exploits. or flash exploits. Basically, people are browsing legitimate websites. They hit a website that has a malicious advertisement. The advertisement exploits their machine. Malware gets downloaded. Xcap extracts a copy of the malware and saves it. Their malware runs on their machine. It runs, matches an ID signature. They get blocked in 30 seconds. So by getting a copy of the malware, running it in the VM, you have a malicious domain name, you have a malicious IP, and you have the structure of a malicious request that you can write an IDS signature for it. This is Snort syntax. This is Snort 8.4 syntax. Any IDS, whether it's a commercial IDS, a Cisco, a McAfee, a Snort, any IDS can properly describe this traffic in a relatively efficient way. And if you don't have an IDS, if you don't want to create an IDS signature, and you have your web proxy logs, or you're reconstructing web proxy logs or something like row IDS, you could do a SQL query to describe this. You could do a Splunk query to describe this. I mean, there are lots of ways to get at this data and find all of the infections on your machine for this particular variant of GBot that does requests that look like this. I don't know. We spent once you've built out the infrastructure, you have the lab, and you have the ability to double click on the malware and look at it. We spent literally 5 minutes. You double click on it, you run Wireshark, you look at the traffic, write the signature, you're done. Move on to the next variant. The cool thing is no matter how much the bad guys change the malware itself, they could have some sort of polymorphic repacker. So the antivirus companies, and they're trying to identify the malware, the executable itself, it could be repacking itself in some polymorphic, changing the key constantly. As long as they don't change the HTTP command and control structure, the actual structure of the request, your signature will keep on matching it. So they might come out with 20, 30, 40 different variants of this malware, and they all match your signature. Because the bad guys, they have to. There's the infrastructure. There's the software that they're running on the client machines, the bots that they wrote, and they have to play this cat and mouse game with the antivirus software. And then there's the command and control infrastructure that they're running, and they have to play a cat and mouse game with takedown notices, where they have to have a whole bunch of different domain names. They have to, a whole bunch of different IP addresses, and they have to rotate their domain names and their IP addresses. So they have to play a cat and mouse game with the network security professionals that are taking down their stuff. But they aren't yet playing a cat and mouse game with the HTTP or with their command and control. So FireEye is doing this, looking at the structure of the command and control. A number of other organizations are doing it, but the bad guys haven't yet caught on to make their command and control polymorphic enough or legitimate enough that a signature can't be written for it. So they'll have their PHP or their Perl or their Ruby or whatever their scripts are running on their command and control that's receiving these requests. And they just parse out the request, and they'd have to change the parser anytime they wanted to change the command and control. Not only that, but they'd have to change what the bots are sending them. So they'd have to, they have this sort of backward compatibility problem. They need to, if they've got 10,000 bots deployed speaking one dialect of their command and control, they can't just go and update it on a whim without also updating all those bots, and they don't want to abandon bots. And they could, say, well, we're going to support the old version of the dialect and the new version, but they just don't do that. They just don't. They don't change their command and control protocol frequently enough to make it even difficult to keep up. It's very easy to keep up. It's hard to keep up with all the IPs they change. It's hard to keep up with all the domains they change. It's very hard for the antivirus companies to keep up with how they change the binary, how they change the packer. It's very easy to keep up with the structure of their command and control. And FireEye's caught on, and that's why FireEye is so successful. And UCSD, we caught on at UCSD, and a bunch of other organizations have caught on. That's why it's so easy to keep up with malware by looking at it on the network. Okay, so I think we are done with Cybot. By the way, in the NetLab malware Cybot, there's a dump.pcap. So there's a pcap file that I captured when I ran this, and so you can go and look at that dump.pcap. And you see, even if you can't get these to run on your machine, or if the command and control is no longer working, or they won't run in Windows 7 or whatever, you can at least look at the dump.pcaps so you can see what it looks like. Okay, so I think we got the malware killed. I think we deleted it in auto runs. So I don't think it made any significant changes to the machine. So So let's get Wireshark running again if you closed it. So I just started Wireshark capturing. I'm turn off NVNS. Now I'm going to run downloader. The reason I called it downloader is because when I sent it to VirusTotal, the names were all over the map. They were just all wrong. So I just called it downloader. So I'm going to double click on downloader. Hopefully it does something interesting. It used to. Well, something sort of interesting.
What was the filter you were typing in, sorry?
The display filter is exclamation point NVNS. It just turns off the NetBIOS name service. It just hides it. Okay, so it's done its stuff for a while. I'm going to stop the capture and go over to Process Explorer. I'm going to kill it. And then I'm going to go over to auto runs and make sure it didn't add anything. Doesn't look like it added anything. Okay. So now let's take a look at this packet capture. So it didn't do a DNS lookup. It just went straight into making a request to 193.105.134.190. Just went straight here. So if we follow this TCP stream, it has an IP address hard-coded, so there's no name for us to trigger off of here. So it just has some IP address hard-coded and some executable name that it's going to try to download hard-coded. So it connected to 193.105.134.190. Yeah, all right. Set the host to some IP address. Didn't set a user agent string. Didn't set an accept language. Didn't set any of the typical headers that you would expect out of a normal HTTP request. So it would be hard to write a signature for this malware. You know, since that looks like a random executable name. But I mean, you could write a signature that says, if you see a GET request for an executable file using HTTP 1.0, only header it has is host, it doesn't have a user agent string, doesn't have a referrer, doesn't have anything like that, it's probably bad. It's not a, it won't tell you specifically what they have, but it'll tell you that they have some software on the machine doing something bad. Unfortunately, this executable no longer exists on this server, so the bad guys have probably been taken down. They were on some hosting provider. They've either left or they got taken down. It used to download an executable, and so it would fire off execap logs. And you'd see execap extract this executable off the wire, and it would run the executable, and you'd get a copy of it, and that was fine. Fortunately, it looks like it was taken down, so there's not much more to show here. No names for DNS lookup. There's not much to trigger on here. So I think we'll move on from this downloader. Okay, so you can just hit the restart button, the start capture, then continue without saving, and we've started a new packet capture. You can clear on the display filter. Okay. So now let's move up to the next thing. We'll go to fake AV1. So I'm going to double click on fake AV1 here. Actually, I could have shown you the packet capture I took of the downloader from previously, but let's not worry about that. Okay. So nice. This is clearly fake AV. Yeah. Great. Windows 7 is about to get more secure. Yeah. So anyways, we'll just ignore all that crap. And it did a lot of name lookups. Take a look at this. So I'm gonna stop our capture. Go over to Process Explorer here. We'll kill any malware, any obvious malware anyways. Go over to auto runs here. We need any extra entries that we got. Okay, I got that. And that. Sweet. Okay, we got rid of that. Okay, so now we're looking at our packet capture here. So let's just take a look at DNS lookups. So if we just type in DNS here. So we see so we look up, it did a lookup for what looked like a bunch of random domains. So you could just add all of these to a list of domains to either blacklist or, if you have DNS logs, anyone looking up any of these domains is probably bad. This is one of the reasons why DNS logs all by themselves are not terribly useful, because there can be thousands and thousands of bad domains, and you never know how long any bad domain is going to last. But it's worthwhile to add them anyways. It did a lookup for Microsoft, why? Probably just to test that DNS is actually working. Did it finally get an answer? Now, it looks like all of the domains it looked up were taken down, because it didn't get an answer for any of them. Which is one of the problems. If you wait, it's really good if you've got the malware to run it as soon as possible, because bad guys have to change their tactics constantly. Their domain's constantly getting taken down. So if you wait a week and then you run it, maybe it's no longer going to work properly anymore. So did it do any HTTP requests? So let's do HTTP. Didn't do any HTTP requests. It tried to connect to to port 80 on several different IP addresses. They've all been taken down. So it looks like this malware has been mostly taken down. So let's go take a look at the dump, see if we have anything interesting in the dump when I ran it last. So it did a whole bunch of lookups for a whole bunch of different domains, did a whole bunch of HTTP stuff. Okay, and it did successfully look up the domain. So let's try to figure out which one it did. Standard query, standard query, standard query. So none of the it didn't give an answer to any of the domains, it looks like. But it did, in addition to doing DNS lookups, it also has a bunch of hard-coded IP addresses, it looks like. Because you can see it trying to reach out to a whole bunch of different IP addresses on port 80. So it gets a
Packet 284.
packet 284, you said?
Yeah.
Here we go. Okay, so yeah, so it reaches out to 204.12.220.139 on port 80, and it gets a SYN-ACK back, and then it acts it, and so it establishes connection. So we do follow TCP stream. We see it do a GET request. It does GET / and then a bunch of numbers, HTTP 1.0. So that's the domain that it thought it was using. Who knows where it got that domain from? And then it uses the user agent string Mozilla 4.0 compatible MSIE 6.0 Windows NT 5.1. So it's pretending to be IE6 on Windows XP. And it should be pretty easy to make a signature for this, or to search for this sort of thing in your logs. How often do you see something do a GET request for an all numbers URL And you might be able to assume 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might be able to assume always 10 digits of numbers, and I would give it like 8 to 12 digits, give it some leeway. On HTTP 1.0, which is unusual, I mean, basically you never see an HTTP 1.0 request for any browser. All browsers send HTTP 1.1 requests. Especially when you do HTTP 1.0, you would almost never specify the host header. Like, it's really inconsistent with what a browser would do. So you could write a signature for this. You'd say, show me, all GET requests that are for all numbers URL with HTTP 1.0. That have a host header, that have a user agent header. You could probably just specify the user agent header altogether. You just say it uses exactly this user agent string. It's set this accept header to */*. You could find this malware relatively easily. You could also make a list of all of the domains and try to look up, and you could look through those in the DNS logs to try to find this particular malware this way too. And I mean, I guess you guys. Maybe the fake AV has died down a little bit, but I'm sure a year ago it was pretty crazy for everyone. I think I ended up with like 30 different fake AV signatures for a whole bunch of different fake AV variants. But 30 is not that many signatures to make when you're finding 20, 30, 40, 50 machines every single day that are compromised with it. And it's also the sooner you can identify a machine as compromised and get it off the network, the less bad it's going to be when it comes to you. People get malware, and that malware will download additional malware. The sooner you get them off the network, the less chance they have of downloading additional malware. And so, if the first thing that you detect is fake AV, maybe that's the third infection that they had, or maybe it's the first and they would have 10, but because you picked them off the network fast enough, they only have 1 or 2. Okay. So if you have the name of some malware, zero access. You could do site threatexpert.com in your MD5. The other option would be sort of the other common one. Someone throw out another malware name. Zeus, which I think it also goes by Zbot. Yeah. Zeus. That does not. That's a Zeus builder. That's the back end that the Zeus bad guys run. Trojan Spy, Zeus, Zbot, Gen. This is much more likely to get. Okay, so they got submitted this MD5. It was detected by Microsoft as Zbot. It was detected by Icarus and OnLab as Trojan Spy, Zeus, Zbot, Gen. It doesn't look. It probably did some sort of sandbox detection because notice that there's no activity in their logs. They don't tell you what processes it ran or anything like that. It probably went, oh, I'm running in a VM, and then bailed out, which is pretty typical for the advanced malware. But you could go and grab this MD5, and then if you had access to the shadow server sandbox API, then you could go and sample download. You can go and download this copy. There's other ways, like sometimes you hear about Zeus, but most of the antivirus vendors call it Zbot, and you wouldn't necessarily do that. Another good way to do it is site virustotal.com in URL. I think the report URL is, or I think the URL is the report. And then you'll see antivirus scan, antivirus scan, antivirus scan. So I just middle click up with a bunch of new tabs. And then, so this Avast detected it as Zeus, GDA detected it as Zeus, no one else detected it as anything, surprise, surprise. And so now you have the SHA-256 of it. The SHA-256, I think Shadow Server also supports searching by the SHA-256. You can also do the more details, additional information. And you have an SSDeep. SSDeep is a fuzzy hash. So a fuzzy hash means that if you have two similar things, then they'll produce similar hashes. Or it's basically like a rough fingerprint. And so Shadow Server allows sorting or searching by the SSDeep. So you could search for this hash in the Shadow Server API, and it will give you a list of all of the samples that match that hash. So it's like a probabilistic fuzzy hashing match. And I also use SSDeep to cluster the malware that Execap downloads. So it'll, all of the malware that's like by hash is grouped close to each other, I'll go and put it in one bucket so that I only have to analyze one or two of them. I don't have to analyze the whole thing. And so here's the additional information. It gives you the names. Here's the sections in the executable, the PE sections. Here's the import table. It doesn't have an export table. And here are the file names that it had when it was uploaded. So it was uploaded as this 1286242, and it was also uploaded as output.1286242.txt. Who knows where those names came from? Maybe that's the name that it was on the machine that the person uploaded it as. There is clearly at least another couple of groups that are running an ExeCap-like program. I don't know what they're running. Maybe it's FireEye. Because when you run ExeCap and you have all these like brand new, fresh off the press malware getting downloaded, if you send some of this malware to VirusTotal, you'll see that it was sent to VirusTotal like 30 minutes before you, and it had some hash name very similar to ExeCap's. But it's not it's not exe underscore and then MD5. So there's clearly a number of other groups that are pulling executables off the wire and sending them to VirusTotal too. It's probably other security vendors. It's probably FireEye. It's probably a number of different organizations. And so you'll see some of that happening too if you're using something like ExeCap. And then we just go to the next tab. This one Packer. This one's a Packer detector. Time AV detector Packer. I have no idea why Google. It was named Zeus.exe, so it's probably not actually Zeus. It's just UPolyX, maybe it's a UPX variant. No other antivirus vendor detected as malware. It's probably not bad. This one's called Zeus IP Theft 1.2.exe. No one detected it as bad. This one was called ZRemover. This one's called, Win32 Zeus, Avast, GData. So this is probably the same sample. Yeah, same sample. So let's go by Zbot instead, because that's sort of the internal name for Zeus, and we're going to get a lot better results. Injector, Zbot, Injector, RegRun, Agent, Zbot, Agent. PWS means password stealer, Zbot, Zbot, Zbot. So this is probably Zeus. I love this. Riskware. Gee, thanks. Generic malware. Malware generic, L. Trend Micro call it T-Spy, Trojan Spy, underscore Zbot. Usually Microsoft is one of the best companies at actually naming this stuff properly. I don't know how Microsoft does it. I don't know if they just have a bunch of manpower or they put a whole bunch of time into naming. But you can usually trust the Microsoft name. They're much better at classifying malware than most other vendors. Most other vendors just lump it into some stupid category. Like Injector, Win32 Injector. What that means is that they ran it in some VM farm. No human being was involved. They noticed that it was injecting itself into additional processes, so they categorized it by its behavior. That's it. They did Injector. Trojan generic, who knows how they identified it? They just gave it generic, they didn't even bother to give it a name. Injector, password stealer, Trojan password stealer, Panda. There's a good chance that, so when you see when you see Dr. Web, some antivirus companies license the detection engine from other antivirus companies, and then they'll often, so if you see, Icarus is one of the companies that relicenses its detector engine, and so when you see Emisoft, Trojan password stealer, Win32 Zbot, Bang IK. Bang IK probably means that it was the Icarus antivirus engine being used by. So Emisoft is probably using Icarus. So if we find Icarus in here, there's probably going to be a perfect match between Icarus, Trojan password stealer, Win32 Zbot, and Trojan password stealer, Win32 Zbot, Bang IK. So there are a number of weird antivirus engines you've never heard of. This is maybe Korean or Chinese, I can't tell. Or Emisoft or whatever, and they've just relicensed antivirus engines from other vendors, and then they just have those signatures, and they'll just mark it as Bang IK for Icarus. Or Dr. Webb probably licensed the Panda antivirus engine, so the Trojan PWS.Panda probably corresponds to what Panda called it. Panda called it just generic malware, but they were probably using the Panda antivirus engine to do the actual detection. And you'll see, like, this is just terrible. Trojan agent gen fake alert. Fake alert. I guarantee you that if it's ZBot, it's not bringing up any sort of fake alerts. It's not some sort of fake antivirus. This is just, it's just an incorrect detection. At least they detected it, but it's just incorrect. Symantec detected it as InfoStealer Banker C. Well, Zeus is a banking Trojan in that it tries to steal all of your banking credentials, that sort of thing. So it's a somewhat, I mean, it's a pretty generic name. It's more of a category than it's the actual malware, but at least it's relatively useful. So here we have Trojan, Win32 generic, Bang BT. I don't know what BT stands for. It's probably, maybe it's Bitdefender? Maybe, yeah, it's probably Bitdefender. Win32 Trojan generic BT. Bitdefender called it Win32, or just called it Trojan generic. And my guess is that BT is probably Bitdefender. You can see the VBA32 is probably using the same antivirus engine as the hacker, considering they both put the injector CPAQ. So even though VirusTotal is using 43 different antivirus products, the reality is that there's maybe a dozen different useful antivirus engines, and they just relicense each other's antivirus engines. Sometimes there's a teeny tiny bit of value add where they have some additional signatures of their own. So injector is some sort of behavior detection. ZBot's an actual family detection behavior. Run LP. Who knows what the heck that probably means that it put a run registry key or some sort of behavior detection. Generic, who knows what that detection is? Generic, who knows? .kd. We've noticed KD in here a bunch. I don't know what KD stands for. It might be, who knows what KD is? Agent. Agent is one of the most generic Trojan names. I don't know. Trojan.agent. It's some generic family of Trojans. I don't know what the criteria are to call something agent versus some others, like small. Like you'll see like Trojan.small, Trojan.agent. I don't know what the antivirus vendors have decided is small versus agent versus some other family. It's just a super generic term. It means nothing. Win32 ZBot, this is so this is a pretty cool detection. So this is Win32 ZBot.du. Who knows what .du is? .gen. Bang Eldorado. So that means they were probably using the Eldorado antivirus engine. I don't know what antivirus engine. Oh, you know what? That's not true. Eldorado is the name of Eldorado is the name of one of the antivirus vendors. I don't remember which one has what they call like this like cloud scanning antivirus service, where it's some sort of malware gets run in a bunch of VMs in the cloud, and they do a bunch of detection. I'm sure you can. Let's try Googling it real quick. I didn't even spell Eldorado correctly, did I? Why spell when you can copy and paste? Web root. Well, I seem to remember, this might just be my own bad memory, but I seem to remember Eldorado being the code name for some antivirus vendors' cloud scanning service. But if we go back to the actual detection, Win32 ZBot.du, who knows what the DU is? It's probably some sort of signature name. .gen, generic. That means that they did not have an exact signature for this malware. They had some generic signature that sort of describes sort of a broader family of ZBot malware. DU probably indicates the signature variant that they had. And then Bang Eldorado most likely means that the signature came from this Eldorado scanning service. I don't think it means it came from an Eldorado antivirus engine. I don't know if that such a thing exists. I think it's the name of some code name for some cloud scanning antivirus service. But this is kind of cool in that they have a generic signature that successfully detected ZBot, which is Zeus. And they didn't use a specific signature. Then we have agent, generic, Panda, password stealer, so this is probably using the Panda engine. ZBot, dash bang IK means they probably used Icarus. ZBot, generic, so they probably had some generic signature or some sort of heuristic. FPROT is also bang Eldorado. Generic KD, it's useless. Injector, useless. Anyways, so that's one of the ways to read antivirus results. So you can, if you want to get a sample, you just, well here, can someone think of another antivirus, or another virus name? Let's go for SpyEye. It's hard to type standing up, boy. Okay, so Microsoft, ourselves called this one SpyEye. Icarus called it ZMunic. McAfee called it VB.fo. Who knows if it's actually SpyEye or not. This is probably not SpyEye. Well, maybe Sophos called it SpyEye. Icarus called it ZMunic. Icarus called it DK. Symantec called it DK. So it's probably a dropper. Well, anyways, if you wanted a copy of this, there's the MD5. You could go to the Shadow Server API, or you could search through. If you're running XCAP, for example, you could try searching through and try to find if you have that MD5. Chances are relatively low. But if you are able to query the API, if you're able to query the Shadow Server API, you don't even need the public access, or you don't even need the private access for this. You could query for the MD5, get the antivirus results or the SSD, then query their database for the SSD cache to get a list of all the other malware that matches, and then you could search for all those MD5 sums. You could search your XCAP logs and get a copy of some other variant that's very similar. And then you can run it in your VM, and you can look at the network traffic that it does, and you can try to identify the domains it looks up. You can try to identify the IPs it contacts. You can try to identify the malware command and control. Does it join the IRC server? Does it do HTTP-based command and control? What behavior can you trigger on based on the logs and resources that you have in your environment in order to detect compromised clients? And I know it sounds like a lot, but it is surprisingly successful. You can find a lot of malware with not that much work. So let's go back to our lab, our malware lab. And so we did fake AV1. Let's do fake AV2, and then we'll skip 3 and 4. Maybe we'll come back to them at the end. So let's get Wireshark actually capturing here. And DNS. Restart the capture. Okay. So we're going to run fake AV2 here. It's got some C icon. Click on that. See it running. While it ran for a second. Didn't do any network traffic. Try that again. It runs, and then it goes away. It might have an expiration on it. We can try running as an administrator. Let's try that. Nope, doesn't want to work for us. Who knows why? What we can do is we'll instead stop this capture, and then we'll just open up the PCAP that I had. So fake AV2 done. Okay, so this is what it did the last time I ran it. So it did not do any DNS lookup or anything like that, it looked like. It just did an immediate connection to 69.50.195.76. We'll follow this TCP stream. And it did this GET request. So AF ID, that most likely means affiliate ID. So a lot of the ways like fake AV works, for example, is they have an affiliate program. And so what will happen is that it's hard for bad guys to take credit card numbers and not get caught. And so instead, they hire some other group of bad guys, and they run the fake AV affiliate program. So they develop the fake antivirus software. They're the one that runs the storefront that people can actually go to and use their credit card and purchase the fake antivirus software. And they don't, they're specialized in taking credit card numbers and specialized in writing the software. They're not necessarily specialized in doing the web exploits to actually get the software running on people's machines. Plus, they're trying to separate out the two ends of the business, the clearly criminal side of things where you exploit people's machines and you get your malware onto them, and the maybe not criminal side of things where you're selling some fake software, which they're usually selling it out of the Ukraine or some other country where it's not even illegal for them to do this. So they sort of separated out the two tasks. They'll run the affiliate program, and then they'll have other bad guys that are experts on exploiting systems or getting their malware installed one way or another. And so those folks, so let's call them, got to come up with names for these things. So we'll say the people running the affiliate program, they're like McDonald's. McDonald's is good at advertising, they're good at designing menus and that sort of thing. They're not good at running actual stores. So they're going to franchise their business out to someone who's going to buy the storefront and put up the signs, and they're going to license the name and everything like that from McDonald's. And they're going to be the ones that actually deal with the customers and get the food in the customers' faces. And McDonald's is going to worry about all the advertisement and everything like that. And so they've essentially franchised their business. And so the way the franchisees make their money is every time they send a sale to the affiliate program, McDonald's, they get some commission back. And so the way they register the fact that they're going to get a sale is they get assigned an affiliate ID. So this group was affiliate 1664. So this is group 1664. Got their affiliate ID, and they packaged the malware up with that, and they got it onto the systems however they could, via web exploits, via malicious advertisements, via fake search results, via any way they could, they got their malware onto your machine. Then they send you to the affiliate program. They send you to McDonald's with their little tag. And then if you make a purchase for the fake antivirus software, then the affiliate 1664 will get some commission, some kickback on the sale. So that's how they make their money. And then, so who are you going to go after if you want to take this program down? You can try to take down the affiliate program. The affiliate program itself, McDonald's, is not breaking the law in the country that they're operating in. They're selling you software. And they're taking your credit card number, and if you complain and you want a refund, they'll give you a refund, and they'll have real customer support and real people answering the phones. And yes, your software doesn't do shit. It's just fake. But they're not breaking the law in the country they're operating in. The people who installed it on your machine almost certainly broke the law to get it on your machine. But they're not the people who, you don't even know who they are. And the affiliate program can say, well, that wasn't us. We strictly forbid using exploits. We strictly forbid doing all this stuff, and they just let their affiliate IDs do it. So they have this, they have sort of this fake separation between the two businesses that is good enough that it keeps their affiliate programs running long enough that they actually make money and they don't get in too much trouble. Eventually, these things get shut down because the credit processors, Visa, MasterCard, that sort of thing, shut them down. Or they're issuing bank or they're acquiring bank. Some of the banks or credit processors involved shut them down. Or law enforcement in that country decides that they're getting too much heat from the U.S. or from other governments, and so they're shutting them down. But so we have this GET request, get IP.php /FID, the affiliate ID, data, and then some hex encoded data string. Who knows what it is? And V equals 3. So it's probably version 3 of the fake antivirus software. Another interesting thing is we have the refer some IP address. We have the host the same IP address. That's completely uninteresting. User int string is uninteresting. The thing that's really interesting is the except */**. It means that the bad guys didn't know what they were doing. you will never see a legitimate browser ever have the accept *//*. It's just not valid. If you made an IDS signature that all it did was look for accept *//*, you would find all the malware that uses that, which would probably be all variants of this fake AV, and you'd never false positive on any browser or anything like that, just because they just didn't copy and paste the accept strings out of the browser properly. They didn't really understand what they're looking at, and they got it wrong. And it happens all the time that they get some aspect of the HTTP headers wrong. Sometimes they'll do like user agent : and then you'll literally see user agent : user agent : and then user agent string. Because they copy and paste the user agent string, and then they put it in the library that was doing their HTTP requests, not realizing that the user agent string was going to get included again. Or when they're doing the string reconstruction, they'll be like user agent : no space Mozilla /4.0 because they forgot to put the space in there. Where they had the user agent part for the header part, and then they had the actual string part, and because they put them together, they forgot to include the space in one or the other, and so they didn't assemble it properly. Or they put the space on both. Like when they were doing the string concatenation, they did like user agent : space as one string, and then space Mozilla 4.0 /4.0 is the other. And then when they put them together, you'll see like user -agent : space, and then the user agent string. They just get the headers wrong all the time. And so if you can trigger on some aspect of them getting it wrong, like PHP, requests to something or other .php, anything .php, don't even just ignore all the parameters, and then it has the header accept *//*. You're gonna trigger on this malware, no problem. So you could create a signature for that. So I would. And then the other thing I would create a signature for is for AFID equals 1164 and data equals, and then so I would I'll create it. I'm sure that I've created it. So let's take a look at, on the NetLab disk in Snort web malware. Open it up. I'm just going to search for AFID here. AFID. Okay, so fake AV fraudware number 1. The content get. URI content PHP, URI content type. The request that we were looking at did not have a type in it, so this is not the right. Yeah, it didn't have a type in it, so that's not the right one. So let's find next. Okay, so here's one. Fake AV fraudware number 24. URI content PHP. It's a GET request. It has an affiliate ID parameter. Oh, this one's looking for sub ID, so that's not it either. Here we go. Perfect. Fake AV fraudware 32. GET request. URI content .php ? AFID content, and it has that accept header. I guess if I were doing this today, I probably would create multiple signatures. I'd create one that says look for any .php with an affiliate ID set, and say with the affiliate ID set and a data equals and a V in the URL. So that would detect this even if they fixed the */* bug. Then I would also create a signature that says match, it has .php in the URL and the accept is set to */*, because then it'll find, so if there's additional variants to the URL structure, but they screwed this up, then you'll catch all those. And if they fix that bug where they actually fix the accept header properly, but they don't change the URL parameters, then you'll catch that too. So you can create multiple signatures out of one piece of malware if you want to. Who knows? Maybe they don't change the user agent string. You might. It's a little bit less. Malware authors like to change the user agent string all the time. It's easy to do. There's lots of them. And also, if you match exactly on a user agent string, there's a good chance it falls positive. They probably just copy and pasted the user agent string out of some browser request, and you're probably going to have that on your campus. And so matching on just the user agent string all by itself is usually not a very safe thing to do. think, yeah, it never ran right, so we opened it out of the dump account. So let's go take a look at so let's go try running. Let's try running a hello to here. I think Hello-T does a request once every 4 hours, so there's a chance we won't see anything. There's a chance we won't see anything in here. The reason why we're running Hello-T is because it's such an incredibly common piece of malware. Let's open the dump that I have saved. So the last time I ran it, it only took 0.45 seconds for it to do a request. So I don't know why it's not doing a request now. Okay. Hello-T is pretty cool because the structure is pretty easy to trigger on. So just do like a get2.php question mark, because the get2 is constant. But you can just do a .php question mark, C equals, and then it's some string of ASCII characters, and then D equals, and then it's some hexadecimal. I never figured out how to decode this, but I know some other groups did. It's probably not easy. It's clearly like not that well encoded. It contains some machine information, operating system versions, that sort of thing. The cool thing is that this C value is derived from the computer in some way. I don't know exactly. It might be like based on MAC address and machine name and that sort of thing. But it's pretty constant. So if you have machines that are DHCPing or they're roaming on wireless and they're getting a bunch of different IP addresses, the machine will always report that ID and it's unique to the machine. And so as they change IP addresses, you see them hop on wireless or go onto wired Ethernet or move around campus or whatever, or go up and down over the course of days with multiple IP addresses, they'll keep the C value constant. It's, like I said, it's the machine identifier. And it's a super common piece of malware, and it's really, really, really easy to write a signature for. It's super easy. So you could try, and by the way, the IP address that it contacts, that 202.150.208.66, it's been the exact same IP address for like 2 years. I don't know why it hasn't gotten shut down yet. Maybe it's in control by, maybe the FBI is in control of it or something, I don't know. But it's just really surprising that it hasn't been shut down. So you could literally just go, show me all HTTP, via NetFlow, show me all HTTP traffic to such and such IP address, it's all bad. Or you can search your web proxy logs, or you can make your snort sig or your IDS sig to match this request. So let me show you what a signature looks like for Hello-T. Snort web malware. Search for. Okay, and then signature 1 is that right there. So get/get2.php C equals set of depth, and then PCRE, and it matches this regular expression. So the only trick when you're writing an IDS signature is you always want to try to detect some fixed string first, and then do a regular expression second. Don't try to just write a regular expression to describe something, because you won't be able to keep up. It'll just take so long to process the regular expression that you'll drop packets in your IDS and you won't be able to keep up. And so all IDS engines that I'm aware of, including Snort, so Snort has this notion of what they call a fast pattern. And so Snort takes from all of your signatures, it identifies some fixed thing of text, and it puts all of those into a fast pattern engine, compiles them all together, and sort of pre-filters all the packets that go by on the wire. And if any of them match the fast pattern, it then checks each one of the signatures. And so you always want to have some fixed string, because there are good fast fixed string search algorithms such as boy, I don't even remember. Well, I used one in Execap, but there are some cool, really, really smart string search algorithms that build what's essentially a finite state machine, and they can search faster than linear time, which is pretty amazing. So you would think that if you're like searching in a megabyte of text, the best you could possibly do would be like a linear scan, looking at each byte and trying to find, does this string exist? But there are actually smarter ways to do it, where the longer the string you're searching for, the faster you can search. And so you build this like finite state machine where you say, for this character in my string, build this table, for this character, build this table, for this character, build this table. And then you can do, you know, like, let's just take a look, I'll show you. So, if you look at Execap real quick, the only reason I'm bringing this up, and the reason why it matters, is that if you're not really careful, it's very easy to write incredibly slow IDS signatures. And if you write a very slow IDS signature, you only be able to have 1 or 2 or 3 before you're just at capacity. And you don't want to be at capacity. So, yeah, okay, the Boyer-Moore search algorithm. So there's a Wikipedia article on Boyer-Moore. And so if you, or you can go and read this article right here. And if you go and read about Boyer-Moore, you'll find that you'll learn that the longer the string, the longer the substring you're searching for, the faster your search goes. So whenever you're making an IDS signature, you want to have as long a fixed string as possible first, as the first parameter in your signature, and all the complicated stuff second. And so get, GET, for GET requests is not particularly fast, or not particularly long, so it's going to be relatively slow to search for compared to, you know, some long string like get2.php $C equals. That's pretty long and it's pretty unique, so the chances of that matching on a packet and then having to run the additional, more expensive evaluations is much, much lower. And then whenever you're doing a snort sig or pretty much any other IDS sig, if you're going to use a regular expression, the PCRE stands for Perl Compatible Regular Expression, regex and snort, or regex and snort syntax, and I'm sure that a SQL database has some regular expression query type parameter too. Always put it last. Always put it last, so that all the other stuff it'll short circuit on that when it fails first, so that it doesn't have to run the PCRE unless it has a really high chance of matching in the first place. So this PCRE would only ever get run if the packet first had a get or a get2.php $C equals. I mean, how often do you see that legitimately on your network? Probably never. And even if you do, it's, you know, if it's 1 in every million or 1 in every billion packets, it's okay to run a regular expression 1 out of every billion times. It's not okay to run the regular expression on every packet that goes mile and wire. So when I was first writing snort sigs, IDS sigs in general, I just wrote a regular expression to match the entire request, and I was like, oh, I'm super happy with myself. And I ran one, and one signature completely, you know, the CPUs are all at 100%, and I'm still dropping packets, can't keep up. Because a regular expression can literally be like 10 million times slower than a string search. So you always want to do the string search as much as possible and then fall back on the regular expressions only when you absolutely have to, and only after you've done a string search. So if you can't find a way to do a string search, the only way you can think of doing it is regular expression, you might not be able to write a signature for what you're looking for. It's better to not write a signature than to write an incredibly slow one. It's better to miss data than to hurt your ability to get any other data. Yes?
Are there any like public databases with latest and good IDS signatures?
Yes. Well, they're not good.
Okay.
But one of them is called Bleeding Snort.
Yeah.
Bleeding Snort has sort of gone commercial, but they do have a, I think it's bleedingsnort.org maybe. They do have a free feed. Nope, that's not it. Oh, Bleeding Snort was the old one. Emergent Threats is the new one. Emergent Threats has sort of gone commercial. But you can go to rules. And they have rules for the different versions of Snort, but rules emerging threats. So this is where you would start. Before you start writing your own signatures, this is where you'd start. You go and grab some, get an idea of what they look like. So I would go for like open, no GPL, 2.90. Rules. I'm going to go by size here. Okay, emerging malware rules, 388 KB of malware rules. And then rule sets. So let's try like ZBot. Let's try Zeus. Doesn't find anything. Malware, spyware, galaxy, so on and so forth. You can see what. Let's take a look at how they did this rule. So this one, content install.php question mark ID equals, and then in the host is set to spygalaxy.ws, so on and so forth. If you look at all of the rules that they have, I don't even know if I went into the right location. I went to the no GPL ones. Let's just go to open, Snort 2.9 rules. Merging malware rules. I think it's the same thing. I don't know why we couldn't find well, I don't know why we're not finding anything useful in here. The emerging threats guys, they know Snort really well, so they write some pretty fancy Snort signatures. For the most part, they don't know malware very well. So I think that even though they write like syntactically pretty fancy signatures, and they know, they know all of the features, and they know all the really, really, really fast string search stuff. Where they'll say like, this string is at this offset, and then this string is within something or other number of bytes. Like they know some really, really, really efficient string matching and string search stuff for Snort. They know the Snort engine very well to make their rules very efficient, very fast. And this is much more than I know about Snort, much more than I know about any IDS. What I don't think that they know very well is malware in general. So at first I ran all the emerging threats rules and I found lots of stuff. So I was like, this is not really, this is a waste of time for us to go track down its spyware or whatever. And have it classified as, possible Trojan or something like that. And also there's just tons and tons of malware that is on your network that they don't have signatures for. So it's worthwhile to run it, but it's not going to be the be-all, end-all solution for you. I think you will find writing your own rules to be very, very, very fruitful, very productive, and very worth your while, even if you also run their stuff. Their stuff's going to catch all sorts of spyware and other weird stuff that you probably don't care about. It might also catch some info stealers. It might also catch TDSS. It might also catch Zeus and ZBot and SpyEye and much other stuff. But they usually write rules that are too specific. Their rules can only ever match one exact variant of some particular piece of malware. Now, I'm not advocating writing a rule that it has a high chance of false positive. I mean, I believe in the 0% chance of false positive. I mean, I don't want anything false positive. I want people to just act on these rules. If it fires, it's pumped. But they don't write rules that are very good for that. They just don't. And I think that they take a very conservative approach. They say, well, we don't really know what we're doing in terms of malware. They know what they're doing in terms of IDS rules. And so they just write very, very conservative stuff. Also, these people they coordinate via mailing list. And so someone will say, hey, I found this on my network, and they'll just copy and paste some really basic stuff. And they don't have the actual packet content. And so they're not exactly sure what they're looking at, and they just have to take someone else's word that it really is malware and that sort of thing. So they're not very good at writing. They're just not very good at malware. They're really good at writing very, very expressive Snort rules. And then I think I don't know what engine is being used internally about FireEye, but I think the FireEye guys are doing exactly what I'm advocating. They have some malware farm. They're extracting executables off the wire. They're running it in a malware farm. They're They have probably some machine learning that does some automatic signature generation. I'm sure they have some human beings doing some signature generation. They're keeping track of domain names. They're keeping track of IP addresses. They're keeping track of executables. They're keeping track of the malware command and control structure, IRC, IRC structure, HTTP. They're looking at all the stuff that I'm advocating that you look at, and they're going to be way better than the emerging threat stuff.
So if you when you manually scan the machine like we did this morning, how do you verify that the rule that actually caught that machine and what you cleaned off the machine matches? Do you base it on?
I never try to do that.
Okay.
I always take the approach that if you've detected one thing on the machine, there's probably 10 things on the machine.
Right.
But the amount of work that it is to try, say, well, I only detected one thing on this machine, I went and cleaned a whole bunch of stuff off of it.
Right.
It's a lot of work to try to go and get copies of those and then run them in your VM farm manually and then make sure you write additional signatures. So I typically don't do that unless it's an infection and there's a widespread infection.
Right.
If you've seen this 10 times in a week, you probably want a copy of it, and you probably want to run it in your malware farm, and you probably want to write a signature for it. But otherwise, I'm just going to rely on the fact that Hexicap went and grabbed a copy of it, and then I'm going to run it in my farm, and I'm going to write a signature for it, if I can. Like when I was doing this at UCSD, I was not doing this full time. I was, doing this, 1 or 2 hours a day. Sometimes I was doing it 8 hours a day. Sometimes I didn't do it for 3 weeks. Just sort of doing it whenever I felt like it, in addition to all my other duties that I had. So there wasn't one full-time person dedicated to just doing this. I was basically doing it less than part-time. And it worked really well. And that's one of the reasons why I think, one person at your school could never beat FireEye because they have, a team of smart people that are doing this full-time. Mm-hmm. But they're also, I'm sure, charging a lot of money for it. So now, if anyone else have any questions? We're basically 15 minutes early. I could continue to show you malware and traffic. I think you guys totally get the idea. So I don't want to be too repetitive.
How often do you go about cleaning out rules that aren't needed anymore?
Never.
Just leave them?
Yeah, unless they're slow. You just never know. If you look at all my rules, they all have a date on them.
Mm-hmm.
So you see, like, SID 2011-01-06-00. So that means it was the first rule that I wrote on that day. I just had a 2-digit number to increment every. So if I wrote 10 rules in a day, it would be just like the last 2 digits would be 10. I never clean them out. The emerging threats guys clean them out all the time when they don't fire. You would only need to clean them out if you're essentially at processing capacity, where new rules mean that you're dropping packets. Mm-hmm. But the emerging threats guys, they have tens of thousands of rules. Right. You would never have that many. If you did this for a year, you'd have 500 rules or something like that. So you would never even come close to at capacity. Plus, the way I configured Snort is not the way. It's not the way any IDS vendor would ever recommend that you configure an IDS. The IDS vendors, they want to pretend that their IDS is going to be able to catch like every possible attack. So one of the things they do is they have these TCP segment reassembly engines, and they have these fragmentation, IP fragment and assembly engines, and they'll reassemble the TCP stream, and they'll be able to match stuff across multiple packets. And doing all of that takes a huge amount of CPU load on the IDS. Doing all the segment reassembly, I turned all of that off, every bit of it. I didn't reassemble anything. I just searched in individual packets. Mm-hmm. So if the GET request was split across 2 packets, couldn't match it. Because if you configure Snort with all of the segment assembly and everything like that, engines, and you turn on all these rules, you'd be lucky to do 100 megabits of traffic. If you could do 100 megabits of traffic, you'd have a beefy box. My Smart box is doing 6 gigabits of traffic, no problem. And that's because any teeny tiny change to the network traffic, if the bad guys even tried to evade it, they would. What I figure, if they're going to try to evade it, they're going to evade it anyway, so why should I waste tons of resources trying to get around them evading it? I'll just detect them some other way. I'll detect them via the DNS queries. I'll detect the malware coming down via Hexicap. We'll detect the IP addresses that they're talking to via NetFlow. will detect it some other way. So don't try to build tons and tons of intelligence into the IDS so that any way that someone tries to get around it, then the IDS will detect them, because that's a losing game. That's a cat and mouse game where the mouse or the cat or whoever, the bad guys are always going to win that. It's so asymmetric. I mean, the bad guys can do anything. You have to anticipate everything they could possibly do, which is impossible. And then you have to build code into your IDS, which the Snort guys and other IDS vendors have done, to try to detect every possible way you could fragment your packets and every possible way you could reassemble your packet. It takes tons of resources, and if you catch 1% more threats, 1% of your attacks were obfuscated in some way, and you detect 1% more, but you took 10 times as much processing power, you've lost. The bad guys have made you do a bunch of work to detect hardly anything more. So I don't recommend that you configure your IDS in that way. At least for your malware detection. For your IDSs for trying to detect exploits and that sort of thing, I'll let your security group do it however they think is best, or your IDS vendor do it however they think is best. But when you're doing it just for malware detection, just turn all that crap off. And then you'll be able to have one IDS do 6 gigabits or 8 gigabits or 10 gigabits of traffic without much problem. And you'll just be limited in the types of signals you can write. If you can't match it all in one packet, then you can't match it. Anything else? Guys, I guess I'm going to let you out early. I really appreciate your time.